Okay, good evening, everyone. I'll start the class in a minute.
Mm-mm.
Okay, this was one of the questions we had done last to last class. Some of you were not convinced with the explanation. So you can spend the first 2 minutes trying to get the answer to this. Those who have not seen this question yet, I'll get the answer to this question in an interesting manner. Okay, try this question for now. After 2 minutes, I'll give you the solution and proof that the solution is correct also. Okay. Once you get the answer, or if you remember the answer, you can put it in the chat. If you don't remember, try to do it new. Arnav, not 18. So the obvious choice seems like you can just make a line that is like this horizontal, correct? That would be 18. But you could make something slightly larger also, like right, like making it slightly slanted because if you use Pythagoras theorem, there is some length over here, there is some width over here. So obviously answer is larger than 18 because 18 is just the horizontal length. So when I say rounded corners, it's the quarter circular arc. Okay. This shape is well defined. It's a quarter circular arc. Yashraj, very good. Yashraj, try to prove that it is the correct answer because I'll show you guys the proof for this. Proof is slightly advanced. Proof is like something you would write in AIME. Uh, but the answer itself is not convincing. Answer will be some line that goes like this. Okay, it's not exactly having endpoints on the horizontal parts of the uh, this rectangular region. It has its endpoints in the rounded region only. Okay, 2 minutes up, I'll start solving it. So this was the solution I had presented in the last class. That you can join the endpoints of this circular region where the horizontal part starts uh, to the horizontal part below. If you do that, what you will find is this circular region has radius 3 centimeter and the entire length is 18. So 18 minus 6 you get 12 and 11 minus 6 you get 5. So we have the central rectangular region and there are these quarter circle regions. What solution I had presented was Arnav, it's an integer. Answer will be an integer. It's 19 only. The answer is that you join the endpoints of this inner rectangle and then extend it outwards. Since all the points on this circular arc are equidistant from the center of that circular arc, correct? We'll say this is 3 then. So uh, this becomes 3 by Pythagoras theorem. If this is 5, this is 12, then you get hypotenuse as 13. So you can add this up and get 90. Okay, what I'm basically doing is we have we want to find the length of largest stick that can be placed flat inside a box with the following dimensions. Its width is 11, its length is 18, and the radius of this rounded corner is 3 centimeters. Okay, so you can see that 3 centimeters inside is the center of this rounded corner. That's what we are using. These points are very, very important. This point is equidistant from all the points on this edge. Now what I'm trying to do is joining the middle diagonal to the radial segments. outside, and I say that 19 is the answer. Now proof for this is that you take any like shape. Okay, if I take a point P inside here, I can get a point on this closed surface that is farthest away from this point P. Let's call this point some A point. And let's say that this is our diameter. This is not the diameter. For what I mean to say is, this is the longest stick. This is the longest stick. Just a second. Does everyone agree that if PA is the largest distance to the circumference, let's call PA equal to largest distance to the boundary from P. If I say this and I call these points M and N, Mn is some longest stick in the region. If Mn is some longest stick in this region, can we say that Pm is smaller than or equal to Pa? Because Pa we are defining as the longest distance from this point P to the circumference. Pm is also some distance, correct? I can join P point and M point. I can join P point and N point. Can I say that Pa is greater than or equal to Pm? Anyone has any confusion over here? You can unmute and ask. If you are unable to understand it, no problem. This is slightly advanced stuff only. But since there are few of you who are able to understand this, you can unmute and ask if you have any queries over here. I am taking any random point inside this region. And the way I've made it, it doesn't look convex, but I'm assuming that this region is convex. Okay. Convex region means if I take any 2 points inside this region, I join it. The entire line segment will lie inside this region. Okay. This point P has its furthest distance from the circumference, let's say at point A. Then for this longest diameter, PM will be smaller than or equal to PA. Similarly, we can say that PN is smaller than or equal to PA. PA is greater than or equal to PN. If we add these two equations up, we get 2PA is greater than or equal to PM plus PN. But if you notice, PMN is a triangle. It will always be a triangle. Okay. PMN is a triangle. Sometimes what could happen is that P could lie on Mn itself. So we can say that by using triangle inequality, this is greater than or equal to Mn. Correct. The shortest distance between 2 points on a plane is the line that straight joins these 2 points. Correct. So Pn and Pm, their sum is going to be larger than or equal to Pn. This is normal geometry stuff. You know the triangle inequality, I hope. That sum of two sides is always greater than or equal to the third side. It can become equal to only if this point P is on Mn. Okay. Now I complete the proof. We get that 2 times Pa is greater than or equal to Mn. Now coming back to our figure. In this figure, if I fix my centermost point of this rectangle as point P, I can see that this distance and this distance are equal. Correct? Because from point P to this corner, it will be 6.5 centimeters. And from this point, if you extend that line to the circumference, it will go about, let's call this A and let's call this B. PA equal to PB equal to 6.5 plus 3, which is equal to 9.5. If I can say that 2 times PA equal to 2 times 9.5, which is equal to, was not equal to, sorry, which is greater than or equal to longest stick, which is Mn. If I can say this, then my proof is complete. Am I not audible?
You are
Uh,
audible.
I am
You're
audible.
audible,
Okay.
sir.
Shubhangi, just try to like increase or play around with your speaker because I think I'm audible to everyone. So what I'm trying to do over here is that I have tried to bound the value of the longest stick. What I've done effectively is that I've taken any random point P. From that point P, I've set the longest distance from that point P to the circumference. Twice of that is larger than or equal to the longest stick. That we showed using triangle inequality. Okay, we take some random point P, the largest distance from that point P to the edge. That distance is greater than two of these distances, PM and PN. If I add these two, they are greater than MN, which is the longest stick. Of course, in any convex region, there will be a longest stick, correct? If there is no longest stick, then you can always make a slightly longer stick, correct? This is not contested. We are not contesting the possibility of a existence of a longest stick. It already exists. Now, if it exists, then twice of PA will be greater than or equal to the length of this longest stick. I have then said that I already know a PA such that PA is equal to 9.5. Twice of PA or twice of 9.5 is 19 is greater than or equal to longest stick. But I already found a stick that is of length 19, correct? By making this construction. This is what is called in geometry a proof by construction. You make something and then later you argue that it is the largest or it is the smallest thing that can ever exist. Then you are done with your proof. Okay, and this is also useful in convincing yourself that you have got the correct answer, even if you are just attempting a objective paper. Am I clear? Anyone wants to ask any doubts? If anything was unclear or if anything just went directly above your head, I'll repeat it once. No doubts. Some of you might have found this very simple. Uh, and some of you might have found it unnecessary. We already found a length, na? It was 19 and it's the answer. But there is no way to actually say that with certainty it is the largest. If I had given you a rectangle, what you could have done is you could have taken 1 point on this edge, 1 point on this edge, said that I'll maximize this, and you could have convinced yourself that ha Pythagoras theorem ke andar we are using the length of this and this. We maximize it and we'll get the answer. But instead, this actually gives you the answer properly. Like this kind of reasoning, okay, twice of the length is greater than MN. You're able to bound it and you're able to get the answer. Right. Let's begin with today's class. We'll do some telescopic summation. If you're already done with it, no issues. Uh, you can attempt a few of the tougher problems. For example, just a second. I'll update the note and I'll share the link to you guys as usual. Okay. Today will be lecture number 9. Uh, 12. Try the first question. 1 square minus 3 square plus 5 square minus 7 square all the way up to 2009 whole square minus 2 square minus 4 square plus 6 square minus 8 square all the way up to 200 2010 square. Okay, there is a plus at the end over here and plus at the end over here also.
So where is
Uh, what happened?
no, sir? I just wanted to ask where is the bracket in the second
Bracket.
question?
Second one, it starts over here and ends over
Yes,
here.
sir.
Okay, this is first question which not everyone will find very easy to solve. So this is second question also there. 1 by 6 plus 1 by 12 plus 1 by 20 plus 1 by 30 plus 1 by 42 plus 1 by 56 plus 1 by 72. Try this instead. Okay, I'll first discuss the answer to question 2, then we'll move on to the other questions. Try the second question first. Akshita, not correct. First one is not correct. Just try it again. Second one I'll start solving, or I'll give a hint towards how to progress solving it. You can see the each of the terms are not random. They have something that is correlating all of them. Okay, they are following a pattern. Like this is 2 times 3, 3 times 4, 4 times 5, 5 times 6, 6 times 7, 7 times 8, 8 times 9. Arna, very good. Correct answer. So you can write this as 2 times 3 plus 3 times 4 plus 4 times 5 plus 5 times 6. Akshita, denominator, you didn't rationalize it or take like fraction properly, but otherwise I think correct. Okay, so see, still the complexity of the problem has not gone away. It's still looking very, very complicated. How exactly to proceed from here? Yashraj, not correct. Try again. Keshav, correct. What you can do is, you can see consecutive numbers in the denominator over here and a 1 in the numerator. Each term has that in common. So what we'll do instead is, we can write 3 minus 2 upon 2 times 3 plus 4 minus 3 upon 4 times 3 or 3 times 2, 3 times 4 plus 5 minus 4 upon 4 times 5 plus and so on all the way up to last term 9 minus 8 upon 8 times 9. Now I can split this fraction out and write 3 upon 2 times 3 minus 2 upon 2 times 3 plus 4 upon 3 times 4 minus 3 upon 4 times 4. Sorry, 3 times 4. And so on all the way up to the last term, which will have 9 upon 8 times 9 minus 8 upon 9 times 8. So if by now you have realized what you are supposed to do, you can try and get the answer. Akshita, correct answer. See something very common that is happening. This 3 and 3 can be cancelled, 2 and 2 can be cancelled, 4 and 4 cancelled, 3 and 3 cancelled. Once you write that down, you will find something interesting, and that is what is the basis of telescopic summation. In like olden times, when pirates and all existed, they had telescopes which were retractable, okay, just to save space. So that's why this method has got its name from there. It looks like a very lengthy sum, but you can cancel off consecutive terms And then this entire lengthy looking sum just ends up having two terms left. So it collapses like a telescope. That is the reason behind the name. What you can find is this is 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus you keep going on until you get 1 by 8 minus 1 by 9. Notice that each of these terms is positive. 1 by 2 is greater than 1 by 3. 1 by 3 is greater than 1 by 4 and so on. All the terms will be positive all the way up to the last term and you will cancel a lot of stuff out. There will be a 1 by 4 over here. There will be a 1 by 8 over here. They will get cancelled and you are left with 1 by 2 minus 1 by 9, which if you simplify is 7 by 8. So there are many other ways to get to the same summation or get a similar kind of summation. All of you can try question 3. 3 upon 4 times 4 upon 6 times 5 upon 8 times all the way up to 10 upon 80. Try this. Hmm, Akshita, the thing is the sum will go on up till the 2008, only up till 2008 because plus minus is happening up till there. Instead of 1005, you have to do. I hope you understood what I'm saying. Yashraj, Keshav, Arnav, correct. Kushagra, try again.
Excuse me, sir. Can you throw question one?
Question 1, yeah. Just a second. Shubhangi, try again. Akshita, correct. Keshav, correct. Kaushik, correct. Daksh, correct. Yeah, if you just cancel a lot of stuff from the numerator and denominator over here also, you will get to the solution. Trisha, uh, answer is double of whatever you have written. Kushagra, correct. Daksh, correct. Okay, question 3. If you write out the entire sequence, you will notice that the denominator is twice the numerator minus 2. So the next the very next term over here will always be twice the numerator and lot of stuff will get cancelled that way. Midinesh, see the point was not to multiply everything out in a calculator or something or in your head. The point was simplifying. Okay, so Yashraj still not correct. Answer is a 4-digit answer only.
Excuse me, sir.
Salman correct. Akshita, go ahead.
Sir, can you please repeat for the mistake I made in the first part?
You found a pattern, but that pattern goes up until only 2008. Okay, 2007 and 2008 over here. 2007 and 2008 up until here. This is not part of that pattern. So
Oh,
once you evaluate all of this, you will get that same stuff that you got. Then you have to separately solve for the last two terms. I think the screen is lagging a bit, but I'll continue with question 3. Just a second.
so is it correct now?
Still not correct. Okay. Question 3 solution coming up. Just a second.
Sir, is it a 4-digit
3,
answer for the first question?
yeah, 4-digit, but it's negative also. Times 4 upon 6 times 5 upon 8 times 7, no, 6 upon 10 times 7 upon 12 times how much?
So the screen is not
Sir,
visible.
I think screen is black.
Just a second. It will come back in. Times 9 by 60. Shubhangi, not correct. I'll just verify just a second.
The screen is not visible.
Yeah, it's back, I hope. Yes. Over here, you can now see we can cancel off 3 from the denominator over here and get a 2.
Sir, we can
8
directly
gets
cancel
cancelled.
the number common in both.
7, 2 is left. Here 2 is remaining. Here another 2 is remaining. Now finally this 2 you can cancel with the 10 over here and get 10. Sorry, 5 over in the numerator. Whatever remains in the denominator is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is not there, only 8. So we are left with 5 upon 2 to the power 8, which is 5 upon 256. Okay, you can notice cancellations happening like this in many forms. So this is one of the forms in which you could identify it and cancel it off. Okay, the point was not to multiply the entire numerator, multiply the entire denominator, and then do some division. That is just waste. You will not end up getting to the answer quickly. All right. Try the next question. Find value of the expression. One times 2 times 3 times 4 times 5 times 6 times 7 times 8 divided by 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Once you're done with question 4, you can also try 1 plus 1 upon 1.
Sir, is my
1
answer
plus
correct?
1 upon 2. 1 plus 1 upon 3. Yashraj, not correct. I think you're just doing some error. Yeah, cancellation is not possible, but you can still simplify the denominator. So is everyone getting the same answer? Oh, exactly. Okay, sorry. Kushagra, Kaushik, and Yashraj, correct. No issues in the answer.
Sir, is the fifth question this much or is it longer?
Uh, it's longer, just a second. All the way goes all the way up to 1 plus 1 by 6. Akshita not correct. Daksh, Arnav, Kaushik correct. Yes, Raj correct. Very good.
Is it correct now?
Akshita correct. Om also correct. Question 6 will be slightly tougher. N is equal to 10 to the power 2020 times 10 to the power 2019 plus 10 to the power 2018 times 10 to the power 2017. So there is a plus and multiplication alternating. Okay, this is one term plus another term and so on, all the way up to 10 square times 10 to the power 1. Find the sum of digits. Of Okay, I'll start with question 4. Atrij, try again. Shubhangi correct. Akshita, Arnav, Kaushik, Kushagra correct. Keshav not correct. Okay, over here there is not much of cancellation happening. It's just that the denominator can be simplified very easily into you can see that 8 plus 1 and 2 plus 7, 6 plus 3, 4 plus 5. All of these are the same number, which is 9. Correct? 8 plus 1 is 9, 2 plus 7 is 9, 6 plus 3 is 9, 4 plus 5 is 9. And there are 4 of these that are existing in pairs. So you have 1 time, 2 times, 3 times, 4 times 5 times 6 times 7 times 8 divided by 4 times 9. And to simplify it, you can just see that 9 gets cancelled from here. 4 also gets removed this way. Whatever remains, you can multiply it out and find k. 7 times 8 times 2 is 112. Multiplied by 5 times 2 is a 0. So you get directly 1120. Yes, Raj, correct answer.
How will
Arnav,
we get
correct.
1120?
7 times 8 is 56, correct? Multiplied by 2 is 112. And then there is a 5 and 2 remaining. If you multiply them out, you will get the factor of 10.
Sir, I think the
What happened?
Sir, I think the denominator is 36.
Yeah, denominator is 36, 4 times 9. So I cancelled 9 out with 3 and 6 over here, and a 2 remains. 4 and 4 get cancelled. Akshita, not correct. Try again. Close to the answer. Okay, fifth question, not very difficult. If you simplify out the denominator, I mean take like fraction and make it a improper fraction, and don't leave it in the mixed state it is in over here. You will find that you get 2 upon 1 times 3 upon 2 times 4 upon 3, because the numerator over here becomes 3 plus 1, correct? And all the way up till here, which becomes 7 upon 6. And so on, 7 upon 6. You notice that 2 cancels off like this, 3 cancels off, 4 cancels off, and 6 cancels off. So we are left with 7 and 1 in the numerator denominator, and that is the answer. Okay. Question 6. This is just a tricky question and no calculation as such is required. See, this number will contain a lots of zeros. This will also contain lots of zeros, but this is obviously smaller than this number. And all of these terms are proper powers of 10. Correct? There is a plus over here. So this is 1 followed by 3 zeros. The next number will be 1 followed by 5 zeros and so on all the way up till here. 1 followed by 4039 zeros. So it'll be basically you'll have to just count up all these terms because that will be the sum of the digits of n. Your first term with 2, last term ending with 2020. Between every term there is a twice drop. Correct? So a drop of 2 that is coming. Someone is 1 plus 1 upon 1 is 2 upon 1, correct? That's how this came. So we see total number of terms. Number of terms. If you want to go algorithmically using a formula, then it's like the last term minus first term upon the common difference plus 1. Okay. But it's easy to actually just use intuition over here. Start from 2. 2 dot 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 all even numbers all the way up till 2020 is just divide by 2, divide 2020 by 2. It's the same thing we have done over here. 2020 minus 2 upon 2 plus 1. So if you don't minus that 2, you will get 1010. That's the answer. So answer is equal to 1010. Explanation. All terms are powers of 10 and contribute 1 to the sum of digits. So if all of them just contribute 1, so you just add them up and you'll get the answer. Now we'll do something that actually gets you closer to the answer of question 1. Okay. Question 1, I'll bring it down. This is still remaining to be solved. Try this question. Evaluate 1 minus 2 minus 3 plus 4 plus 5 plus 6 minus 7 minus 8 minus 9 minus 10 and then plus 11 plus 12 and so on. This is question number 7. I hope you are able to understand. 1 minus 2 minus 3, then plus 4 plus 5 plus 6 minus 7 minus 8 minus 9 minus 10. So this is 1 unit, this is 2 units, this is 3 numbers, this is the next 4 numbers, and this keeps going on until you reach 91. Try to think about this one.
प्रांजल नहीं है क्या क्लास में?
Keshav, not correct. Try again. Just a minute. I'll just explain this question once, if someone didn't understand. So I'm taking the first term and then I'm subtracting the next two terms, next two numbers, then adding the next three numbers, then subtracting the next four numbers. Then I'm adding the next five numbers. This keeps going on until I reach the number 91. If you want to know what order this is in, this is the fifth set of numbers, fifth set of, this is the next five numbers, and this will be the final 13 numbers. Okay, so every odd position number are being added all the way up till 13, and then these even position numbers are being subtracted.